Once you've classified something as a salt, then you're going to have to further classify it to decide if it's going to dissociate into ions or not. Notice it says these rules only work if you apply them in order. The first rule is hydrides and oxides do not dissociate. So if it's sodium hydride, iron oxide, any one of those categories of compounds, those do not dissociate. Your second rule, and you can apply these components kind of in any order, this is kind of a little mnemonic device. Sagan dissociates into ions, anything that fits into this category. The S stands for sulfates, which is SO4 minus 2. Any compound that contains the sulfate ion, any salt that contains the sulfate ion dissociates into ions, with 3 exceptions. Calcium sulfate, barium sulfate, and strontium sulfate. Strontium sulfate, SrSO4. The A stands for acetates. The acetate ion is C2H3O2 minus 1, or you can write it as COO, well, let me write it correctly, CH3. Well, let me just start again. CH3COO minus. Any salt containing the acetate ion is soluble. There are no exceptions to that rule. The G stands for group. Any compound containing a group 1 cation, lithium, sodium, potassium, rubidium, cesium, francium, does dissociate into ions. Any salt containing an anion from group 17 dissociates into ions with some exceptions. And I left off that except up there. Here you have 3 exceptions. Well, except silver and then whatever that group 17 anion is, mercury, and it's mercury 1. So it'll have a formula like this, and lead, 2. So any compound that contains a group 17 anion, unless it's one of those 3 compounds, does dissociate into anions, or ions in general. The A stands for the ammonium salts. Ammonium is NH4 plus 1. Any salt containing the ammonium ion is soluble. It dissociates into ions in water. The N stands for the nitrate ion, NO3 minus 1. Any salt containing the nitrate anion dissociates into ions. Now this covers a wide range of compounds. These are very common anions and cations that are present in lots and lots of salts. If, however, you exhaust these rules and you never had a hydride, an oxide, a sulfate, an acetate, the cation wasn't in group 1, the anion wasn't in group 17, it wasn't ammonium, it wasn't nitrate, you go, well, what do I do? You have 2 final rules. You look at the charge on the anion. If the anion is -1, it dissociates into ions. If the anion is -2 or -3, it does not dissociate into ions. So let's flip over to page 17 and look at deciding if the thing dissociates or not. You probably would want to take that paper out so you could refer to it, yes. right, so the first thing that you do is you look at the classification that you've already determined. So for magnesium chloride, acid, base, salt, weirdo, none. Salt. So you go to the bottom half of the page. You're going to start with solubility rules for aqueous salts. And you look at the compound that you're given. Magnesium chloride, MgCl2. You look at your very first rule because you have to apply these rules in order. Is it a hydride or oxide? No. Then you go into Sagan. S, does it have the sulfate ion? No. Does it have the acetate ion? No. Now that group rule sometimes is hard for students to understand what you're talking about. Here's the way you ask it. It's two separate rules. Look at the cation. Is the cation from group 1? No. Then you look at the anion separately. Is the anion a component of group 17? Yes. So if you look at your rule, it says compounds with group 17 anions are soluble unless the thing it's bonded to is silver, mercury, or lead. So is this one of those exceptions? No. So does this dissociate in water? Yes, because it is a soluble one that does dissociate. Okay, do you think you can do this? Yeah. Okay, now I never actually made the point and said, notice the list that you have today doesn't have the none on it. Right? Yesterday we said acid, base, salt, weirdo, none. I didn't give you a rule for do nones dissociate. Nones do not dissociate into ions. That's why they're classified as nones. When you put them in water, they don't split up, they don't do anything, none of them ever. They always remain completely together. The reason acids and bases kind of have a separate rule is because some of them are weak versus strong, and so. So what I'd like you to do before class tomorrow, please, is just that page 17. Okay, classify just the ones on page 17, and then that'll give us some time to make sure you're using the rules appropriately, because especially next year we'll use this every test. We'll have a section of stuff like this on it. So you really need to be sure you understand it.